Hey, so in this week we are looking at an article written by Yashvardhan Kukreja. Yash is here with us, and we'll talk all about cars. And Yash, do you want to introduce yourself a little bit?
Yeah, thanks. So I'm Yash. I'm currently working part time in Red Hat as a software engineer, working on a bunch of cloud native stuff like Golang, backend engineering, Kubernetes. Also, apart from that, I'm doing a master's at University of Waterloo from Canada. So yeah, that's pretty much about me. And yeah, I just like to tinker with this kind of backendy stuff. Lately, been exploring systemsy stuff, and yeah, this Discord channel has been pretty fantastic with that.
Yeah.
So yep, that's pretty much about me.
Thanks for the plug, Yash. So this is part of the Binary Orbit Discord server where we, just read through interesting articles on a weekly basis. And this week we'll learn about cars. So the ways we are going to work through this is we're going to read through this article and then pause for any sort of explanations by Yash. And if I have any questions, I'll also ask Yash along the way. All right. So let's start reading. So
Awesome.
yeah, cool. So if you yet another write-up on cars, right? I mean, a car seems like one of the, to me, right? It feels like one of the most obvious things that we all learn, but eventually not get enough grasp of after a point where we have something important to ship and then cars hits us on the face, right? So it's one of those things that always seems to happen to me, and I think and eventually over the years I've sort of grown to understand it far better. So let's see how this article can help us in that as well. So okay, so if you thought of this, I don't blame you, but I assure that this write-up is not like the others. It won't just talk about the what and how of cars, but actually dive into the painful story of me in this case as a Yash facing some not so common issues with cars. It will be a tale of pre-flight requests with hidden redirections, a ton of betrayal with browser caching, and even bugs found in server-side framework. So this is a two-part series, and I think this one we are going to look at just a part one. I think in the future we can schedule another one where we go through the second part. Right? Okay, so let's read the blog. CORS, as we know, is cross-origin resource sharing, and it is a fancy name. It is a security mechanism embedded into all browsers: Chrome, Firefox, Safari, which is the one I'm on. All have them, right? And the clothes around security are sarcastic, and which I'll explain in the end is what he says. Okay. So this is sort of the Elify version of explain like a 5-year-old, explain it to a 5-year-old kind of an explanation. Of course, okay. It's kind of sad for a 5-year-old to know about this, right? I mean, that is the state we are in. I don't know how much of the education market in India you've been through, right? Everybody is starting to do programming at this age. So 5 years. I mean, if you ask around someone to say 5 years is a tad bit too late, right? You should start at year one, right? So. But okay, anyway, again, that is very sad. So let's say say you're a kid, you call a store and order a 13 plus movie accidentally, and the store receives this request and delivers that movie to your house the next day. Your dad opens the door but checks the movie label and notices that it's for 13 plus kids, realizing that you're not supposed to watch that movie. So he throws it away and scolds that you aren't supposed to watch it, right? Okay, so your dad is essentially blocking you from watching it. So you're not a 5-year-old, so everybody in the audience is not a 5-year-old. So we are going to read the actual explanation of what cars is. So let's take an example. Say you wrote a backend API for some friend's website, which is foo.com. You expect that any random web page apart from foo.com should not be accessible to the API. Okay. Despite this, a web page of a different website called unknown.com tries to make requests against the API because it's mischievous, right? Yeah. When that web page does that, the browser notices this and drops the incoming data as it realizes that unknown.com doesn't deserve to receive any data from the backend API. Okay. Right. So this is essentially, so I'm just reading through a diagram. This is the browser and you're trying to reach the backend API. And you get the unknown.com is also trying to reach your backend API, but it returns a cause error because unknown.com does not deserve to know the data, right? In ideal scenario, foo.com will be able to talk to backend API, I think, and get back the right data. I think that's sort of sums it up correctly, right? Anything I'm missing here, Yash? I think.
No, you're all good. I just wanted to talk about the word origin and the word cross origin. So normally this word cross origin resource sharing it is derived from the word origin, which is pretty much analogous to the browser URL of the website which you have opened right now. And normally, what the browser follows is the same origin policy.
Right.
Same origin policy is basically that the browser does not like it when a certain website of, let's say, domain a.com makes a request to a different website URL, domain b.com. That is a cross origin request or a cross different browser URL request. And a browser only likes if it's made to if it's made to the same domain.
Right. Right.
Now, how does domain b.com tell the browser that, hey, it's fine for domain.com to receive my responses, all of that stuff? This is where this blogs comes into the picture and tells you that how can you basically make, your browser deal with cross origin requests. So here you go.
Yeah, I think that perfectly sums it up, right? Okay. So where's the analogy for the 5-year-old kid, which is the web page is you, your dad is the browser, a typical dad, and the store is the backend API. The movie is response to data, which is meant for the 13-year-old, and the dad checking the label is the cars the browser checking the cars. The dad scolding you is the browser showing a cars error. So essentially, this is the one-to-one mapping for a 5-year-old. Again, very sad, but no, let's not go there again. So. So technically speaking, what does all of this do, right? It's mostly, as Yash is saying, it's cars mostly has to deal with the headers, right? And the headers that contain some metadata which are headers that contain metadata about the request and response, right? So I think we can safely say that we know what headers are, but do you want to quickly walk through what you're talking about here?
Sure. So basically what's happening is that, if we talk from a very high level perspective, whenever you open a website on your browser, behind the scenes, there's a very high chance it's going to be talking to an API, like some backend it's going to be talking to. And usually it talks to those APIs in the form of requests. Now, a bunch of a major chunk of requests tends to be REST oriented. So I'll be talking in the lingo of get, post, all that stuff as shown in the example. But basically your web page is making a request to certain website, right? Now, what happens is that this request contains some information that what it is trying to access, and usually the request consists of the URL, which is the location where you want to hit the request, the verb, which is more like a semantic way of telling that what kind of request are you making, and the body, just let's say, just to basically, if you're, let's say, creating something, then what are you creating, that content is sent in the body. But that is usually the payload. But beyond the payload, there tends to be some meta information about the request, that what is the size of the request, what is the format of the request, is there some token we are sending in the request, and that is usually not conventionally speaking, not sent as the part of the payload itself. Rather, it's sent into a different section called headers. So a header is basically just the information about the request you are sending or the response you are receiving. So just like when you send a request, you can send more information about this request through request headers. Similarly, when the backend responds you with a response, the backend can also attach a bunch of response headers to share information about the response.
Right.
So that's pretty much about it. So if I give a very simple example, there are various protocols being used behind the scenes nowadays. For example, there might be certain backends or certain browsers which might say that, oh, hey, you can talk to me with HTTP3, which is a more optimized protocol. So that can be something which can be communicated through the response headers of your backend. So that's just one example, right? Here I have attached a snapshot of it, that if you make a post request to google.com with some data, automatically, if you look at the Chrome Dev Console in the network tab, it has a snapshot of all the information about the request you sent, and you can see all of this default information it sent. That it used the scheme of HTTPS, it was using the gzip encoding for encoding the payload, all that kind of stuff, all that stuff. So long story short, its headers contain the information, it's a meta information about a request and response.
Right, that's perfect. And if you want to know more, I think the HTTP header section on MDN is a really good resource.
MDN is a Bible for web dev. Yeah.
But like this usually goes into a lot of different things on like, and if you specifically the cache control, I like this one a
Yeah.
lot.
Man, this header is a mess of header.
It is a very like a difficult header to deal with if you don't know what you're doing, and
Yes.
it can save you a lot of money also if you know what you're doing with it. So it's one of those
Right.
types of headers. But but I think this is like a really good resource if you want to know. So as Yash was mentioning, right? So essentially how client and server talk to each other and pass that additional information for every HTTP request and response. Metadata, you can call it metadata, you can call it additional information. Either way it works. But most of all of these headers are case insensitive. So essentially you can do it lowercase. And the another one additional thing that I think has come up a lot more recently after I think 2012 is I think even before that people were doing it. But if you can add your own custom headers. So a lot of servers use this to pass in specific contextual information from the client to the server and vice versa by just prefixing your own headers with the X, and so that is part of the RFC, that is part of the HTTP spec to allow that. I think this is a really good resource. So yeah, so that's HTTP headers, the TLDR of that, right? So okay, so okay, so how does so I think we'll go move on to how CORS fits into this picture, right? So anytime a server sends a response back to the web page, the browser first checks the response headers. It checks whether the host name of the page which where it originated the request from is mentioned in the access control allow origin, right? So this is another important header that the browser checks whenever a request comes back from a server, right? So if this particular header is mentioned, the browser realizes this web page deserves to talk to this API and passes the response forward to the page, right? So yes, so I can think of this as some of the gatekeeper, right? So essentially this guy is
In very simple words, ultimately the backend through the means of response headers is telling the browser that, hey, certain web page, certain websites are allowed to access this response. Or if we provide a wildcard like an asterisk, then the backend is essentially saying that, hey, I don't care whoever called this from wherever possible, everybody is deserved to read this response.
Correct. So
at
you
this point.
right. So if you add an asterisk, that means that you're essentially allowing any you're effectively allowing cross origin requests from any origin, right? So that's what the the star or asterisk means. But if you specify, let's say if you specify an origin, like let's say you're in this case your origin is in this case if it's google.com, you can do you can take any request from star.google.com. That means any subdomains of Google can access this particular backend and then get the response from that, right? So that's what. So this is an allow list. This is not a block list. So this is essentially saying only this person can allow, right? So so that's what.
And not only this, actually, the nice part is that so what Shriram mentioned just a few seconds back about how a few years back you can provide custom headers. Now, if you think in terms of the browser, this also seems kind of weird. That what if a client is flooding quite fishy headers to the backend, and the backend is responding? So the browser also would like to ensure that the client is not sending any unintended headers. So just like this access control allow origin, helps communicate from the backend that which origins are allowed to view that response.
Correct.
Similarly, there's an access control allow headers field, which is set by the backend to tell that only these certain headers can be set by the client,
Right.
which will come to later on. But yeah.
Right. So that's another like quote unquote security mechanism you could say, right? Because so essentially if you say access control allow headers, you cannot pause any headers that sort of try to mess with the backend system in any sort of way, right? And that's sort of that's sort of the gatekeeping mechanism that these headers allow. Right. So okay. So if it is mentioned, the browser realizes this web page deserves to talk to this API and pass the response forward to the web page. Right. I think this we sort of understand, right? We have a get request from google.com. We use HTTP 1.1, and then the backend server responds with the right page. But the browser sort of interrupts this request, and it checks if the access control allow origin has google.com, and then since it has it allows you to view that page. Right. So.
Right.
Right. So the browser realizes that the backend is not even aware of this web page website, and so the web page shouldn't be allowed to consume that backend API. Therefore, the server drops the response and throws an error. So this is the so this sorry, I think I misread it. But if this allow access control origin header isn't mentioned, then that means that is when that is your error case, right? That is essentially what the server says. No, this guy is not someone who I know, or I don't know this person, so I can't allow him to essentially view this whatever content that I'm throwing at him, right? So that's the reason why, and it throws an error. And this is what the error that throws. The error that throws says that it's the access to fetch at google.com from a different origin has been blocked by CORS policy. I think this particular this thing is coming from a Chrome extension, right? I think you took a screenshot.
Yes. Actually, so I opened a new tab and my new tab runs an extension, so that's why it's showing like that.
Right. But yeah, so that's what we have here, and but this is typical of anything, right? Even if you try to do to a different origin, and you're going to see the same error in your browser, right? And so I think we sort of understand. It is just a can I made this, yeah. Oh, so it's because since it's in the new tab, it shows up as this one, is it?
Yes. So I opened a new tab and I opened a Chrome Dev Console there. And in my browser, personally, I've installed an extension which shows random wallpapers in the new tab. So that's why it has that extension thingy with it. And that's what I mentioned here below in italics.
Okay, but even if without the extension, if you do it on your normal console also, it's going to error, but it's not going to say the extension part of it. It's going to say the current window.url, whatever you are on.
Yeah.
Let's say if you do itnext.io, from there, if you from itnext.io, if you try to do a request to google.com, it's going to say the same thing, but it's going to say that from origin itnext.io, you cannot access google.com, right?
So basically, again, as I mentioned previously, origin is the current, at this present moment, at this point in time, the browser's URL. So as Shriram mentioned, if we right now open the dev console, at that point in time, the browser URL, which is origin, is itnext.io/whatever.
Yeah, so this is Safari, but yeah, windows.location.origin is going to show you the actual origin, right?
Perfect. Yeah, that's it.
Cool. All right, so yeah, I think we got that. How do we fight this error? So just don't use the browser. So the CORS is a security mechanism. Well, a CORS it's a browser specific thing, right? So if you, it's not so I'm trying to understand what you mean by here, right? So we have it is not necessarily a browser specific thing, right? Or is it? I'm trying to understand what you're saying here.
I mean, like this is where I might be, I don't know, wrong or something, but this is what I've noticed, that CORS happens to be injected in a lot of browsers. I haven't noticed this happening in a lot of other places, especially if you're writing your own script. It's not like it's a kernel embedded thing where the kernel interferes and checks that, okay,
right.
headers are...
Okay, no, I think I got it. Yeah. But you can technically allow even if you write in your node server, right? If you write your own server, you can have you can parse the same CORS headers and get like if you try to access something that is like if you write a backend API that is trying to hit google.com, you would I don't know if you would get the same error, but you can still, there are ways for you to put like a CORS mechanism similar to what you have on the browser, right? Is what I meant. Yeah.
That's absolutely, that's like one of those authorizations which you can of course add. But out of the box, it happens to be around browsers. That's what I've noticed.
Correct. That's perfect. That's what I think. That's my understanding as well. So so if you have a simple use case of calling a backend API, just use a local script or a HTTP client like Postman, right? Okay. So tell the browser you don't care about incoming data. Sometimes you just don't need some data to the server without caring. You just need to send some data to the server without caring about what it responds with. For example, your web page wants to insert or post an object to your backend without caring about the response. Something like a fire and forget. Yeah. So CORS is all about blocking the incoming data, but nothing stops from sending the data from your web page to the backend. Can you brief what you're saying here, Yash?
So basically what's happening is that ultimately the CORS check happens after the response reaches from the backend to your browser, right? So your request is sent to the backend, it goes successfully there, the backend does a bunch of processing, it responds with the JSON, and that's when the browser interferes, performs the CORS check, and realizes that whether your web page deserves to see that response or not. But what if you are doing a fire and forget kind of thing, that as the caller of that API, you don't care to even read that response. You are like, okay, I just want to send that request to the backend, and say if I don't deserve to see the response, the point is I don't even care about the response. So just drop it. There is no point checking whether I deserve it or not. Let's just make it invisible and perceive it as a successful situation, right? So in that case, you can provide a mode as no cause, and in that situation, what's going to happen is that the browser won't give you an error, it won't throw an error, it would still give you a response, but it would still respect the fact that you don't deserve to see that response. So the response object to receive is not a normal textual response which you can pass. It's an opaque object, more like an invisible object which you can't read. So again, the browser still continues to ensure the security, just that the semantics have changed a little bit, and it does not raise an error that, hey, you don't deserve to see this. And as the caller, as the client, you achieved what you wanted to achieve. You just wanted to send a request and you forgot about it. So yeah.
Right. I think this, just now that I think about it, this is actually even more useful in a scenario where but you don't expect a response at all, right? I mean, post,
Yes.
you can like post. I guess that if you make a post HTTP request, you can expect a response. It's not you,
Right.
but if you do a delete, for example, right, where
Yeah.
your the HTTP verb does not, you don't send a response back in a delete, right? So in those scenarios, I think it makes a lot more sense. If it's, I think that is where you fire a delete request, and then essentially, even if it is, you can pass in a no course mode, and you don't particularly care about the response anyway because it's a delete, right?
Exactly.
But again,
Anywhere where you are expecting a 204 no content, there is no point in reading it, sir.
exactly.
For
Right.
example.
Right. Yeah. So 2.4 content is the status code when that servers, just for context, is what servers will respond back whenever you there's literally nothing to respond back with. Right.
Right.
I mean, you have to make it explicit but by default, if it's 200, right? By default, if it's a success response, it's 200. But you'll have to explicitly say there's nothing that I want to respond back with that specific status.
Yes.
I mean, I have seen weird scenarios where people respond back with an error with a 200, but yeah, let's not go there.
Oh my God.
Yeah, that's not REST. That is not at all what REST stands for.
Yeah.
Yeah. Okay, cool. So therefore, your web page, when making the request, can set the mode to no cause, and that browser that doesn't want to. Right? Yeah, makes sense. So you, what if you want to sneak into the response nonetheless? That's what you were saying, that the response is essentially an opaque object, basically
Yes.
an object that's a placeholder, and the browser's way of telling you that the cause protection of hiding the incoming data from you. Okay, so now I'm intrigued. Since you're saying it's an opaque object, is it? It's an empty string, is it? Oh, it's literally
Yes.
an empty
It's
string.
empty.
Okay.
It's literally an empty string. It's
Okay.
nothing.
So
Yeah.
they don't even hide it with something. They don't mask it. Nothing. It's just an
No,
empty
nothing.
string.
There's no obfuscation. Nothing. Is just an empty string. Yeah.
Oh, that's interesting. It's very interesting. I'd love to see like some why. I also would want to know if this is like a browser specific thing, right?
Yeah, I tried this on Chrome. I'm not sure exactly if this is exactly how Firefox deals with it. I would assume it to be the case to stay compliant with that thing, but yeah.
I mean, browsers do all sorts of weird things, especially with
Yes.
cars. They do all sorts of weird things. I've seen like things changing very differently. Like I think Chrome was the first one to enforce the same origin policy, right? It was the first one. Yeah, yeah. If I remember correctly, right? I might be wrong, but Chrome. Yeah. I remember that this was when did this happen? Is there some history to this? I don't know. Yeah, I think that's, well, let's not dig into history, but yeah, I remember this being, or maybe it's not the first one. I think it became the default.
Yeah.
Right, like right, and like I think it's more difficult to turn it off right now than it was earlier on, probably. But yeah, I think there are still like extensions that allow you to, there are like Chrome extensions that allow you to disable calls and all of that. But
Right. Right.
Okay, cool. So even if you try to read through this opaque response, you'll get only an empty string. So that's something that new I learned. I did not. I mean, I honestly haven't tried fighting too much with cars because I sort of submit myself to the car slots and just listen to what they say. So at this point, I'm just like, yeah, just give it the right origin and then call it a day, right? Or if I'm super annoyed,
always did that. I
that,
always did that since forever, but like I went through an issue which we'll be covering later, where I was forced to deal with cores, and I just had to perform all these tweaks. Like for example, the first time I read no cores, I thought, oh wait, more no cores. I mean, it sounds like something which will
right,
help me
right.
bypass cores,
No,
but
no,
well,
no,
no,
that's not.
that's
Yeah, yeah. I mean, I explicitly remember doing the exact same thing like 4 or 5 years back, like or even earlier, like when I was just starting programming, like 6, 7 years back, right? When I was just writing my first Node API or something like that, and then I was like, this is no course. Then I'll just bypass course. Like, why is everybody just crying about course? I was like, oh, that is not what this means. Just
yeah.
yeah, okay, but I mean the this resort, the option that everybody resorts to just pass star in the backend and then call it a day, but that would just make things way worse, sir, if you are dealing with anything in a production system, right?
Yeah.
This is not a way to go about it. Probably if you're the only person you're doing it, if you want to like prototype, you just or I mean, you just have a backend server that you just want to play around with, you want to learn some things, if it's your own side project, all of that is great. I think anything that is more real world, you probably don't want to do this, considering the fact that if you don't want people snooping around your server and trying to hit your server with random requests, I don't think this is a good idea, right? Yeah, so the actual solution normally which people follow but requires you to own the backend so that you can reprogram it, right? So this is in scenarios where you own both the UI and the front end and the backend. So with this strategy, your web page doesn't directly call the backend, it calls a proxy. Okay, so
Yeah.
so the other way you get around this is to call a proxy when you don't own the backend. You can proxy to a separate server, and that backend proxy places the access control allow origin star header or asterisk header to the response and further passes it down the browser, right? So the browser that sees the header gets happy and hands you over the response, right? So this is the I'm going to zoom this on this a little bit. Okay, so the proxy here is an nginx proxy, right? And you make an unknown.com request to myproxy.com. That passes it
So the
on
blue
to.
text is so the blue text is what the change was made by the proxy. So we made a request to myproxy.com, but it updated the host to google.com while keeping everything else the same. That's why google.com is blue.
Right.
And then the response came from the backend, and the proxy intervened and added its own flavor of allow access control origin again in blue, and the browser saw it as all cool, so I had proceeded.
Yeah, so the proxy is basically your middleman, your wingman,
Yeah.
you can call whatever. So if you want to access something that you cannot, you introduce a proxy, and that does all the magic of handling the headers for you, right? So here you can see the access control allow origin header is set to a star over here, and here specifically it's changing the origin. So it's as Yash was pointing out, so it's changing myproxy.com to google.com, right? So yeah, I think that makes sense. So ultimately, the proxy is talking to the actual backend and in a browserless way, right? So essentially, what we have done here is, since we said, I mean, this is sort of ties back to the earlier discussion, right? If browsers are your problem, remove browser from the equation. And how we are doing that right now is introducing a proxy as the client that talks to the actual backend and then sort of just relays back the response to the browser, right? Perfect. So
What is about to come in the blog might be a bit controversial, maybe because and this is my understanding, of course, although I'm not a proper web developer, but I'm not exactly sure if course achieves the so-called security per se. More like it just makes it inconvenient for the front end to make undeserved requests. Because if, let's say, as an attacker, if I see that my web page is trying to make a request, which I want to make, by the way, and it's failing because of course, I can just pull out all the cookies, I can just pull out all the basically request payloads from the network tab and just feed that to a local script and bypass course in that way. Don't you think?
Yeah. So okay. So there are. I sort of agree there, but here's my thought process. Right. If you are if your browser cannot protect you from the most basic of attacks,
Yeah.
what is it good for, right? It is a tad, makes it things a tad bit inconvenient, yes. But
Okay.
I get what you're saying, right? People who want to, who you have the intention of going around this, have like 100 different ways to go around this, yes. But someone who, imagine someone who just started understanding what they just took a hacking 101 course, right? They do
Yeah.
not right, so they don't understand. They just started doing baby steps. They're just taking baby steps, doing SQL injections and random websites and all of that, right? They're doing all of that. And in those scenarios where you can't get your way around that, right? The browsers, the bare minimum that a browser can do is this, right? So that your website server is not bombarded with requests from something that is you don't intend it to be, right?
Right.
So think of that's the way I think of it as, is it's not it doesn't like nothing in the nothing is you can't make anything that is non vulnerable today, right? Like there are loopholes to everything, and any software you write effectively has some way, right? Not just software, and even hardware has issues, right? So you have issue, people will go till the final bit, till they get to exploit that vulnerability, right? We have so many folks like that, right? Both black hat and white hat hackers who can do like crazy amount of things that you and I cannot fathom, right? But for the script kiddie who just started yesterday, right? The browser should do the bare minimum to stop them from making a CORS request, right?
Right.
Yeah, and browsers keep doing inconvenient things time and again, right? It's just that I think like as much inconvenience as this is, I think what would help rather is if there's a lot more knowledge about why this is happening, rather than like if a lot more like beginners understood why like, or a developer would like, if when I am developing a website, I would right now think that this has one of the most important things, like along with developing a website, if you're owning both the front end and back end, this is something that every engineer that I talk to has come across at some point or the other. So that means that everybody is going through the same thing, going through the painstaking realization that this is not this there is a quick fix, but they don't entirely know how to fix that, and they don't know why it's there in the first place, right? So I think just making a lot more people aware of this can circumvent that problem, just the inconvenience problem of it, right? But at least
Right.
I don't know if I will be able to sleep peacefully thinking that I have the right course headers and everything, right? Because if someone had the intent, I think they could obliterate any server at any point of time, right? So
Exactly, and that's what I meant with this small message, that as a backend engineer, ultimately, the way I should code the backend should be independent of whether the client is a browser safeguarded by CORS
perfect.
or a script, whatever it is.
Yeah.
Obviously, but yeah.
No, that makes 100% sense, right? You know where your users are, but you don't always anticipate where your users will be, right? They
Yes.
could be coming from any client, any. I mean, you can do a lot of things, right? You could do user agent spoofing, just to make sure that it doesn't even look like you're from a browser, and like there are a lot of
Exactly.
sophisticated attacks that you can do to a server, right? Like and even headers in that sense, right, are pretty important. Like say, like for example, I remember a very specific header where sort of skips my mind. I think it's X made with or something. I forgot. It gives you the version and the program that is. I mean, what language or what framework you used to build that server with, right?
Yeah.
Is it X version? I don't know if I want to search X version right now. X version ID.
Yeah.
Just a sec. So let's say for example, where this is useful is where it used is let's say if you use an older version of PHP, or like an older
Right.
version of
Right.
Node, for example, that is known to have a vulnerability, right? And
Oh, okay.
essentially
Nice.
people use that particular header to understand you can intercept and then say this server is made with this particular this thing, and so you can try to attack it with vulnerabilities and known vulnerabilities from that particular version. I sort of
Interesting.
skips my mind. HTTP header that exposes PHP version. Hex powered by, yes, that's the one.
Okay.
So X powered by header. So, and if you look at the OWASP cheat sheet, I think explicitly they mentioned that you're not supposed to. So OWASP is I think security principles, right? So they have
Yeah.
there's a standard set of principles, and here you can see, right? Yeah. So the recommendation, they specifically say what is the recommendation for you, right? You could have these are all conventions of different servers. Like ASP.NET, you used .NET, right? It added, whenever you added this by default in the server, it would spit out this as a header, right? And the
Oh,
recommendation that they say is you're not supposed to like explicitly in your web.config disable this particular header, right? And so
okay.
this is also a header that, as I mentioned, right, that describes technologies used by the web server, and this can using this information, the header attackers can find vulnerabilities much more easier, right? So you have to explicitly make sure that your server does not return an export by header, right?
Right.
I think like one. I mean, let's we can check one particular thing, if what the recommendation regarding course is, since we talked about course. Course origin resource. Yeah. Yeah, so I'm just going through all the recommendations whenever you're dealing with course. I think this is sort of a good place to finish.
Yeah, nice.
So validate URLs that are passed. So any URLs that you are coming to your XHR request, right? Your XHR, whether it is an XML HTTP request or a fetch request, right? They're all separate. They're both separate protocols, but like any fetch request that comes from you, always validate the URLs as one particular thing, and then ensure that URLs corresponding with this particular thing that we told, right? Access control allow origin as star does not include any sensitive information. So even if you have any specific URLs that you want to be accessed across, make sure that those are URLs that are either that are publicly available information. I don't want to expose any specific anything that is sensitive information, right? When you are talking about when you are passing this particular header in your server response, allow only selected and trusted domains. Again, this is also a known thing, right? If you own both the UI and the backend, you know your exact domain that you use. So make sure
Right.
that you set the origin allow origin headers accordingly. Yeah, and this is so a course does not again prevents the requested data from going to an unauthorized location. It's still important to perform CSRF. So CSRF is cross-site request forgery prevention. So that's another thing. So a CSRF attack occurs when like a website or something like that, and it tricks an authenticated browser into performing an unwanted action, right? So that's a CSRF request. So even if you have like the right cores, the headers, you still have to make sure that you do the right things for CSRF.
Right.
Yeah, so this is the fetch standard like recommends a pre-flight request or an options request, right? So
Oh man, this thing is what actually led to the creation of this blog and the next part actually, that how and pre-flight requests are further cached, that if let's say your browser made a pre-flight request to a certain URL and it failed with a CORS error, and let's say now you sorted out the CORS issue, the next pre-flight request you'll make, you'll still get the error, and that would be instantly because it's actually fetching that from the cache. So you either use that cache control header, which which we talked
right,
about in the beginning,
right.
or a simpler way is just to open the dev tools, and there's a disable cache checkbox in the networks tab.
Yeah.
You can do. But yeah, man, pre-flight requests are a beautiful thing, and I mean, they're painful but beautiful thing, and that's what I've emphasized in the next part of the blog actually.
Yeah, that's a great segue for the next this thing. So let's do that sometime in the future. So okay, so
Yeah.
discard any request that received only over plain HTTP with HTTPS origins to prevent mixed content bugs. So essentially, this is another a set of errors that you get, right. Essentially, if you're on localhost, right, and if you try to hit a server that is on HTTPS, right, this is another error that you would get, is because you cannot make a request from a server that is HTTP and then that goes to HTTPS, because you're using different protocols essentially, right. So the one the HTTPS is secure, HTTP is not secure. So you'll get a mixed content error in most cases, right. That I think, I don't know if that is always explicitly blocked, but I do know that you get an error when you try to do something like that.
Yeah.
And don't rely on the origin header for access control checks. Browsers always send this in cost request, but yeah, that's what I was saying. You can spoof it outside the browser also, right?
Right.
So this is sort of the user agent spoofing, or like the origin header spoofing. To in this particular sense, user agent is another header. But what I meant is you can change the origin header also. Like essentially, what we are sort of doing with the proxy, right? We are technically spoofing the header with the proxy when a request goes to the proxy from the browser to your server, right? So that is also possible. I think application level protocols should be used to protect only the sensitive data. I think this is like a really good list, and I think yeah, I think
I
lot
think
more people should
this
read this.
entire cheat sheet can be inherited from this. Have you heard of Hiram's law?
No, I haven't.
So it's actually an interesting thing which I read recently in one of the conference random talks, and it's a pretty straightforward. It sounds something very obvious, but if you think about it like very deeply every time while designing an API, you'll probably design much more secure API. So the idea is pretty simple that any system you develop, or in like if we talk in terms of backend, any API you develop, any exposure you expose will end up getting used no matter what. So there is no point hoping that, let's assume you wrote an endpoint and it's accessible by randomly someone. Don't just hope that, oh wait, but nobody knows about this endpoint, so they can't access it. No, there will be someone eventually who might, maybe through social engineering, maybe through brute forcing or whatever, they will eventually explore this API and they will eventually try to exploit it for their own use case. Now that can be to compromise your service or just getting their own use case. So long story short, this exactly sums it up, that if you're backend is still, like hoping that course step would happen and any exposures which it is exposing would be guarded by course, that's wrong. As per Hiram's law, the exposure of your backend would still be accessed through spoofing or whatever you do.
By any
So
means
ultimately
possible. Right.
just design your APIs, design your backends in a very restrictive manner, considering they'll be out in production, irrespective of what's the user agent, what's the source, what's the client, and just look at it from the perspective of Hiram's law.
Yeah. Now that I know about this law, I'm getting flashbacks of all the side projects that are
Exactly.
of servers that have been running from my college that that did not follow any of this. I think after this call, I'm just going to go and close all of them down. But yeah, I think jokes apart. But yeah, this is really good write up. Yash is, I mean, sort of goes into. We didn't go very deep into the whys and whats, but we also went to a level where this is enough amount of information for someone to for someone who's dealing with cause errors to have a good takeaway from the article, right? I think the next one I think is even more deeper, as you were saying, right? The next, yeah. So I think let's look forward to that. So I guess this is great that you already plugged in yourself in the end of the blog. So yeah, just feel free to follow Yash on all of these socials, and I guess we'll meet in the next session. Yeah, hopefully
Perfect.
at
Yeah.
some point. Yeah. So thank you, Yash. Thanks. This was great. Thanks a lot.
Thank you for having me.
Yeah. Thanks a lot. Thank you. Bye bye.